Hello students, welcome back. Let us continue with chapter 13, the volume of spheres. So I'm going to explain you volume of spheres and hemispheres. So how do we find the formula? First of all, we will learn this through an experiment. Let's take some cylinder filled with water. Okay. Now what I'm going to do is I'm going to place this cylinder in a trough. And then I will take metallic balls of varying radii. Let's say this is the first metal ball with radius R. Okay. Now this cylinder is filled unto the brim with water. When I place the sphere inside the cylinder, some amount of water will spill into this trough, right? Because since it was already filled until the brim, I placed a sphere. So because the sphere was inside, some water spilled out and we have collected into this trough. Now this water that is collected into the trough, I am going to place it in the measuring cylinder and measure the amount of volume that is present using the measuring cylinder. So again, this is filled unto the brim. The same cylinder filled with water is placed in a trough and a sphere is placed into it, and whatever water is spilled, we are collecting into this measuring cylinder and measuring the volume. Again, I am going to take another, and what I am going to do is I am going to measure the volume. And let's say this radius, we have seen that the radius of this metallic sphere was R. Let's calculate R. Let's calculate something 4 upon 3 pi R cube. You will notice that this value is going to be equal to the volume of water measured in cylinder. Similarly, you are going to take spheres of different radii, you are going to find the volume, you are going to find this value 4 upon 3 pi R cube, and also the spilled water you are going to collect into the measuring cylinder and find the volume. You will see that in all the cases, this value is equal to the volume of water measured into the cylinder, which means, see, whatever amount is spilled is equal to the volume of the metallic sphere, right? We have collected here. So, in short, we can deduce the formula for volume of sphere. Volume of sphere is equal to 4 upon 3 pi R cube. So, this was about a sphere. How about a hemisphere? Hemisphere is half of the sphere. So, that value of hemisphere, the volume of a hemisphere is going to be half the value of sphere. So, which is going to be volume of hemisphere is equal to half volume of sphere, which is equal to half into 4 upon 3 pi R cube. So, if you cancel, you will get this to be as 2 upon 3 pi R cube. This is the formula for volume of hemisphere, whereas this is the formula for volume of sphere. So now we are going to take a look at a solved example on page 235. Very simple question. Here we've been given the radius of a sphere. We need to find the volume. So without wasting time, we will just substitute the value of R into the formula of volume of sphere, which is 4 upon 3 pi R cube, and we will find the answer. So I'll say solution. Volume of sphere is equal to 4 upon 3 pi R cube, which is equal to 4 upon 3, pi is 22 upon 7, and R cube is 11.2 cube. So let's calculate this. I'll write this as 4 upon 3 into 22 upon 7 into 11.2 into 11.2 into 11.2. So let's check if 7 can divide 11.2, 7 ones are 7, okay. 7 ones are 7, 7 ones are 7, 7 6 are 42. And nothing else is cancelling. So I'm going to multiply all these values and divide it by 3. So 4 22s are 88. And we have 11.2 into 11.2 into 1.6. So let's quickly calculate this. 11.2 into 11.2. So 2 2s are 4, 2 1s are 2, 2 1s are 2. Then you have 1 1 2 and 1 1 2. So 4 4 5 2 1 and 2 decimal places. We have 11.2 into 11.2. This is done. So now I'm going to multiply it with 1.6. 6 4s are 24. 6 4s are 24 plus 2, 26. 6 5s are 30 plus 1, 30 plus 2, 32. 6 2s are 12 plus 3, 15. 6 1s are 6, 7. And I have 1 2 5 4 4. So 4 4 5 1 2. Let's add this. You get 4. Okay, 4 and 6 plus 4, 10. 4 plus 2 plus 1, 6. 5 plus 5, 10. 7 8 9 10 and 1. Let me just write this properly. I think I have just messed up a little bit. So here 4 4 5 2 1. I think now it's neat. So 4 0 4 5 6 7 0 0 and 2. So how many decimal places? 1 2 3. So 200.704 into 88. So 200.704 into 88. So what I'm going to do is I'm just going to write 200.704 into 80 plus 8. Let's check. You get 0. 8 4s are 32. 8 7s are 56. 8 0s are 0. 8 2s are 16. And how many decimal places? 1 2 3. So 16056. This is divided by 3. This entire thing is divided by 3. Plus 1605632. And how many decimal places? 3. This entire thing divided by 3. So let's calculate. 1605632 and 6325061. You get 259 11 6 again. One 16056.320 and 632.5.6.5061. So 259 11 6 6 7 1. So I get volume is equal to 17661.952 divided by 3. So I'm going to have to erase this section. Let's calculate. 17661.952 divided by 3. So 3 5s are 15 minus 2, 3 8s are 24 minus 2, 3 8s are 24, 2 and 1 comes down. So 3 7s are 21, 0. I'll bring down this 9 and I'll put a decimal point here. Then 3 3s are 9. Now we do not have much space, so let's do this orally because we just have 2 more decimal point places. 3 1s are 3 minus, so 2, 3 7s are 21, 3 3s are 9, 3 3s are 9. So this keeps on repeating. So finally what do we get our answer as? This is approximately equal to 5887.32. Why 32? Because I am just taking 2 places after the decimal. Now this number, the third point after the decimal point is greater than 5. So I am just going to add 1 to the previous term. So this becomes 5887.32 centimeter cubes. This is the volume of the sphere. So please take a look at the solution. And revising, the volume of a sphere is 4 upon 3 pi r cube, whereas that of a hemisphere is 2 upon 3 pi r cube. Thank you for watching this video.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.